Section 6.3 is separation of variables. We're going to continue to look at differential equations and solving differential equations by separation of variables. What we're told is that if we are given the differential equation m of x plus n of y times dy over dx is equal to 0, if we collect all the x terms on the same side with the dx, and we collect all the y terms on the same side with the dy, you can obtain the solution through integration. Again, that process is just called separation of variables. So it just has us putting all our x's together on the same side of the equal sign with the dx in the numerator, all the y's on the same side of the equal sign with the dy in the numerator, and integrating both sides of the equation. We want to find the general solution of the differential equation, and then we are told enter your solution as an equation. In WebAssign, you are going to be asked to enter your solution as an equation, which means you're just going to make sure that you write that equal sign there. It's not asking us to solve for y or any variable in particular. So number 1 is dy dx is equal to 3x squared divided by 8y. The first thing we want to do is put all our x's on the same side of the equal sign. So I have to move this dx to the other side to get it out of the denominator, and I need to keep it with my 3x squared. So we end up with dy is equal to 3x squared over 8y times dx. Now I want all my y's on the same side, so I have to multiply both sides by 8y. I have 8y dy is equal to 3x squared dx. Now that I've separated my variables, I integrate both sides. The integral of 8y dy is going to be 8y squared over 2, and that's going to equal the integral of 3x squared dx is 3x cubed over 3 plus c. Cleaning this up, we end up with 4y squared equals x cubed plus c. So in WebAssign, you would actually enter this 4y squared equals x cubed plus c because you want to enter your solution as an equation. You don't have to solve it for y, for c, or for x. You can just integrate it and then just make sure that you're entering your solution as an equation. Number 2 is y times y prime is equal to negative 8 cosine of pi x. Well, the first thing we want to do is rewrite y prime as dy dx. So we have y times dy over dx is equal to negative 8 cosine of pi x. Then I need to separate variables. So here are all my y's, and I have to get the dx to the other side so that it's out of the denominator and with my x's, so I multiply both sides by dx. And we have y dy is equal to negative 8 cosine of pi x dx. Now let's integrate both sides. Integrate the left and integrate the right. The left is pretty easy to integrate. The integral of y dy is y squared over 2, but the right-hand side is going to need a u sub. Well, we can factor out that negative 8 constant multiplier and rewrite this as negative 8 times the indefinite integral of the cosine of pi x dx. So if we let u equal pi x, the derivative du would equal pi dx. Well, I don't have a pi dx, I just have a dx, so I divide both sides by pi, and 1 over pi du is equal to dx. Bring down your y squared over 2, and that's going to equal, don't forget about your constant multiplier of negative 8, and that's going to be times this 1 over pi times the integral of the cosine. Instead of pi x, I write u and then du. Well, the integral of the cosine of u du is the sine of u plus c, so we can write y squared over 2 multiplying negative 8 and 1 over pi. We'd get negative 8 over pi and then sine of u plus c. finally get out of u's and go back into x's, and we end up with y squared over 2 is equal to negative 8 over pi sine of pi x plus c. Number 3, we have the square root of x squared minus 16 times y prime equals 11x. The first thing we want to do is rewrite y prime as dy dx, and then we also want to rewrite this radical with its rational exponent. We'll write x squared minus 16 raised to the 1/2 power times dy over dx is equal to 11x. Now we need to get all of our x's on the same side of the equal sign, so I have to multiply by the dx and divide by x squared minus 16 to the 1/2. All that's left on the left is dy, and that's going to equal 11x over x squared minus 16 raised to the 1/2 times dx. Now we're going to integrate both sides. The left-hand side's pretty easy. The right-hand side is going to require a u-sub. Notice that 11 is a constant multiplier, so we can pull that out of the integral. Let's go ahead and integrate the left-hand side. The integral of dy is going to be y, and then we'll write this as 11 times the indefinite integral of x over x squared minus 16 to the 1/2 dx. So if u is equal to the denominator, because that's what's being raised to a power, then the derivative du would equal 2x dx. Well, we don't have a 2x dx, we only have an x dx, so we divide by 2, and 1/2 du is equal to x dx. Bring down our y here, and y is going to equal, don't forget about your 11 times this 1/2, the integral of du over u to the 1/2. Well, u to the 1/2, getting that out of the denominator, is just going to be u to the negative 1/2. So we have y equals 11 over 2 times the integral of u to the negative 1/2 du. Using the power rule to integrate that, we'd get u, raise it to 1 more, and that's going to be positive 1/2. Divided by 1/2, well, since it's a fraction, we're just going to multiply it by the reciprocal of 1/2. The reciprocal of 1/2 is 2, and then plus that constant of integration. The 2's here cancel, and getting out of u's and going back into x's, we have y is equal to 11 times x squared minus 16 raised to the 1/2 plus c. And we can keep our answer that way, or we can write it back in radical form. Y is equal to 11 square roots of x squared minus 16 plus c. Either answer is correct. Number 4, e to the x minus y times y prime is equal to 0. Well, I want to make sure that this term over here is positive because it contains my y prime. So the first thing I'm going to do is move it over to the right hand side. I'm going to add y times y prime to both sides of the equal sign, and we end up with e to the x is equal to y times y prime. Now get rid of your y prime and make it a dy dx, and you end up with e to the x is equal to y times dy over dx. Now notice that my x's are on the left this time, so I'm going to have to multiply both sides by dx to get all my x's together. And my y's are already together here on the right. So we end up here with e to the x times dx is equal to y times dy. Well, both of those are pretty easy to integrate. So we're going to integrate both sides. The integral of e to the x dx is just e to the x, and the integral of y dy is y squared over 2 plus c. Now notice I put the plus c with the y term instead of the x term. It doesn't matter which one you put it with, but I went ahead and just kept it consistent and put it on the right hand side. So you could have entered this in for your answer, or your answer could have been e to the x plus c equals y squared over 2. Both of those are correct.